Hello and welcome back to 5-Minute Chemistry. Previously we drew a few Lewis structures and I mentioned how we can use the concept of formal charges to be able to draw better Lewis structures. So let's take a look at some examples of that. First we will be drawing the carbon dioxide here. So as we do, first we need to count the valence electrons. So carbon has 4 valence electrons, oxygen has 6. And this is a molecule, so there is no charge. We don't have to add any electrons or remove any electrons because of that. So number of valence electrons in this molecule will be 4 plus 2 times 6, which adds up to 16. Next, we can draw the basic structure of this molecule by writing down the symbols of the elements for the atoms and connecting them by single bonds. And we can fill up the octets of the non-central atoms, which will mean these oxygen atoms. So they all need 6 additional electrons to have 8. So we will give them these electrons and then we should put the remaining electrons on the central atom, but we already used up all 16 valence electrons that we have. So we need to move electrons from the non-central atoms into bonds so the central atom can have the octet structure. And I know that there is a solution for this that most people will think about, but actually you can do it 2 different ways. The way that most people would think about it is just have 2 electrons from one side and 2 electrons from the other side and make 2 double bonds here. But actually you could just move all 4 electrons from one of the oxygen atoms and get a single bond on one side and a triple bond on the other side. So both of these will actually fulfill the octet requirement. So 8 electrons on the oxygen, 8 electrons on the central carbon atom, and 8 electrons on the right-hand side oxygen. There is of course a big difference in these 2 structures. One of them has 2 bonds that are the same and one of them has bonds that are different. So you could just do some experiment and check which one is correct, because we already discussed that the Lewis structures have kind of a low predictive power on how the molecules in real life would look like. But we can improve this predictive power by applying the formal charges here. So we can actually minimize the formal charges, but first we need to take a look at what the formal charges are in these 2 Lewis structures. So we will split up all the bonds and then we will count the valence electrons and compare them to how many valence electrons the atoms would have if they would be just free atoms out in the wild. And so in the top case, for the oxygens, there are 6 valence electrons, which is the same as the number of valence electrons in the oxygen atom. And for the carbon, it is 4 valence electrons, which is also the same. So neither of these atoms have gained or lost any electrons. All of them has 0 formal charge. In the bottom Lewis structure, on the other hand, so first of all, the carbon has 4 valence electrons, so it did not gain or lose any electrons. It has a formal charge of 0. But on the left-hand side oxygen, we have 7 valence electrons, which is 1 more than the 6 it should have. So it gained an electron and it has a 1 minus formal charge, while on the right-hand side oxygen has 5 electrons instead of the 6. So it has a formal charge of positive 1. Of course, in both cases, if we add up the formal charges, we should get 0, which is the total charge of the molecule, which is neutral. But if we add up the absolute value of the formal charges, we will see that the top Lewis structure has 0 as the sum and the bottom one has 2. And actually, the Lewis structure with the minimal sum will be the more accurate Lewis structure. So that will be more close to the reality. So we can cross out the bottom Lewis structure and we can say that in a real carbon dioxide molecule, we should have 2 double bonds, so both of the CO bonds in this molecule should be the same. Okay, let's take a look at another example here, which is NCS-. This is a polyatomic ion. Let's take a look at the formal charges here. So, of course, we will divide the bonds equally, and we'll see that the nitrogen in the first Lewis structure has 5 valence electrons, which is the same as the atoms. The carbon has 4 valence electrons, which is also same as for the atom, but the sulfur has 7 valence electrons, which is 1 more than the 6 valence electrons sulfur would have. So it will have a formal charge of -1. If we add up all these formal charges, the sum will be -1, which is the same as the charge of the polyatomic ion. in the second Lewis structure, we can see that the left-hand side, the nitrogen actually has 6 electrons instead of 5, so it gained an electron, formal charge -1. Carbon has 4 valence electrons, and sulfur has 6 valence electrons, which is 0 formal charge. And in the third case, this nitrogen actually has 7 valence electrons, which is 2 more than the 5 it would have in an atomic form. So this is a formal charge of -2. Carbon, formal charge of 0. It has 4 valence electrons again. And sulfur has only 5 valence electrons, so it lost 1. Its formal charge is +1, so we can add up. This is -2 + 1. This is also -1, so formal charges always add up to the charge of the polyatomic ion. But if we take a look at the sum of the absolute values, then the one with the largest sum, we can cross it out and then ignore it from any further discussion. But we have to decide out of these two, which both have 1 as a sum for the absolute value of formal charges, which one is the better Lewis structure, which one describes reality more accurately. And here we can remember back when we learned about polar bonds and the electronegativity. So electronegativity tells us which atoms are stronger in grabbing electrons for themselves. So if we look up the electronegativity of these 4 elements, then we will see that nitrogen has 3.04, which is the largest among these elements. And that means that it is more likely that the nitrogen will carry this negative charge than the sulfur. So based on the electronegativities and the formal charges, we can make the prediction that actually the second Lewis structure will be the one closest to how this polyatomic ion looks like in real life. Okay, so this is it for today, and I will see you tomorrow.